Let's go get the other 4. So what we have so far is the first 2, right? You got sine's derivative is cosine. You know that. And you got cosine's derivative is negative sine. That's what the first one was. Now we're going to go, we can prove that these are true, and then we're going to show that the other ones are by using little tricks. So as long as you know just sine and cosine, you can get everything else for free. All right? That's why I show this, because we all brain fart. We can forget. So knowing this, typically in an in-class situation, I would 100% test you on this. I would have you do this process in class. Online, maybe not so much. But let's go look at tangent. Let's go mess around with old tangent first. So let's just say that y is equal to tangent of x. Let's go find its derivative. Let's go find its derivative. But let's not do that, bro. There's no such thing as tangent. There's only sine and cosine. Oh, look. It's a quotient. It's a quotient. So as long as you know the derivative of sine, you know the derivative of cosine. Shit, there's nothing to go. All right, so low cosine of x times the derivative of high. What's the derivative of sine? That is cosine minus high sine of x times the derivative of cosine. Derivative of cosine is negative sine of x. And then we're supposed to square the bottom. Cool. So what's that? Cosine times cosine. That's cosine squared. Cosine squared down there. Don't cancel that shit out. Don't you dare do that. That negative has to come over here. We get a negative and a negative. That creates a positive. So it looks like we have cosine squared plus sine squared. Cosine squared plus sine. Wait. No. That's 1. Sine squared plus cosine squared. That's 1. And then if you flip your 1 over cosine squared, you get secant squared. Secant squared. So the derivative of tangent is secant squared of x. There it is. All right. On to the next. We're running through. We're going to do all 4 of them. You can see all 4 of them. Let's go. Now we're going to move down to our cosecant of x. We'll move to that. There might be a reason why I'm color coding too. I'll be able to show you something. So cosecant of x. We want to take this. We want to go find its derivative. Right? We'll take the derivative of cosecant of x. Let's go. So y prime or dy dx or however the heck you want to do it. Oh, don't do that. There's only sine and cosine, dude. There's only sine and cosine. So here's how we go. We're going to be like low, all right, sine of x, times the derivative of high. Well, the derivative of the number is 0. So that shit's going to go away. Minus high times the derivative of low. What's the derivative of sine? Cosine. Square the bottom. There we go. There it is. So well, that goes away, and we're left with negative cosine of x over sine squared of x. And here's this little trick. We're going to break it up just a little bit. I'm going to break it up. Sine squared. So let's leave a sine here, but let's break one off and bring it over here. Now the game is we're just going to put a 1 on top of it. Because we don't want to leave negative cosine over sine squared. We want to write it down as like just a combination of stuff. And we can see that this is going to be, what's cosine over sine? Yeah, that's cotangent. And do you know what 1 over sine is? That's cosecant. So whether you write it as cosecant cotangent or cotangent cosecant, as long as that shit's negative, we're good to go. So we're going to take that and we'll pop it on up here. We'll say there's our next one. And I'll write it as negative cosecant of x cotangent. That's typically the way my brain sees it. Same thing. Multiplication is commutative. Okay, on to the next. Now we're going to do secant. So we're going to look at y is equal to secant of x, but that's the same thing as 1 over cosine of x. So we're going to run through and do the same process we just did with cosecant, because it's essentially the same problem. It's not the same, but it's close. So we're going to say, all right, 1 over cosine. So it goes low, cosine, d high. Well, derivative of 1 is 0. Minus high, well, that's 1, times the derivative of low. The derivative of cosine is negative sine of x. And then we're supposed to square the bottom. Cool. So let's see what this turns into. This is going to be Well, that just goes away. We get a negative and a negative, so we get a sine of x up on top over cosine squared of x. Now we're going to do the same thing we did from back here. Remember where we had our square and our thing up there? Well, it's the same game. We got to break it into a couple different pieces. So once we do that, depending on how you want to do it, maybe we, oops, I don't want that. I want this. Maybe we do sine of x over cosine of x. And then we move our cosine of x over here because it's a multiplication. And we just slap a 1 on top and go, well, that looks like tangent of x times secant of x. And there's the derivative of secant of x. And we pop that in. Actually, I'm going to write it backwards. I'll write it backwards. Secant of x, tangent of x. Just showing you that both cosecant and secant have themselves inside their own derivative. Lastly, we're going to go do cotangent. So we'll jump over here. And we say that y is equal to cotangent of x, but you already know the trick. You got the trick. Huh? There's no such thing as cotangent. There's no secant. There's no cosecant. There's no tangent. There is only frickin' sine and cosine. Don't you forget it, huh? Sometimes it gets us out of trouble because there's so much in trig to memorize. Here we go. Low times the derivative of high. What's the derivative of cosine? Negative sine. Minus high times the derivative of low. The derivative of sine is cosine. Square the bottom. It's your sine squared of x. So let's clean it. We got sine times negative sine. That's negative sine squared of x. Minus cosine squared of x. Do not cancel out those sine squareds. I know it looks tempting, but we got a negative and a negative. Why don't you just factor that out to the front? You know what I mean? A little something like that. Factor it out. And then what's sine squared plus cosine squared? That's what I thought. That's what I thought. It was just 1. So we get negative 1 over sine squared. That is negative cosecant squared of x. And bang, we got them. We got all 4 of them. Shoot. So we get negative cosecant squared of x. Now I'm going to babble on for just a little bit. Maybe it can help you see some patterns. So let's look. Sine, tangent, and secant all have positive derivatives. All their derivatives are positive. Everything in black is positive. Everything in blue has a negative derivative. But let's see how we could, see if you can't tell how we can always tell when it has a negative derivative. Cosine of x is negative sine of x. Cosecant of x is equal to negative cosecant of x, cotangent of x. Cotangent of x has a derivative of negative cosecant squared of x. Do you get it? Do you get it? Functions derivatives are negative. Sine, positive derivative. Tangent, positive derivative. Secant, positive derivative. So if you're saying your derivative better for it can be negative. There'll be little tricks as we go through a lot of these things. Trig, inverse trig, hyperbolic. When we get to hyperbolics, it's a trig thrown on its head. So make sure that we have these. These are fundamental. You're supposed to know these through the entire calculus series on lock at any given time. So start working on getting them dialed into your head. Maybe just do 1 a day. Get sine and cosine for sure, and then maybe just start building up your repertoire. Know them, love them. I'll see you in the next.